Hi guys, welcome back to our channel Unknown IITians. Today we are going to discuss logarithmic functions. Today we are going to cover logarithmic functions and graphs, natural logarithmic function, exponential functions, how to solve them, and properties of logarithmic functions and the change of base rule. Okay, so now let's get started. First thing, what are logarithmic functions? Simply we can say that logarithmic functions are inverse of exponential functions. They are inverse of exponential functions. See here, let us consider this example only. If we are given 2 cube is equal to 8, then how do we represent this in the logarithmic form? Okay, this is how you write it in the logarithmic form. 8 2 is equal to 3. Observe here what the terms are changing. 2 is termed as base, 3 is exponent. We have discussed this in the previous lecture itself, and this is the result. Okay, see here we are writing result, and 2 is the base, 3 is the answer. So this we say this as log 8 to the base 2 is equal to 3. Okay, in general when you are given in the exponent form, this is how you convert into logarithmic form. Okay, and here we can see the graphs of the logarithmic function when the base is 2, and here we have two different cases when 0 is less than, when a is less than 1 and greater than 0, and a is greater than 1. Okay, now let's discuss some properties. See here, let us say f of x is equal to log x to the base a. Okay, now here for example, suppose if a is greater than 0, we can say that the function increases. And if a is 0 less than a less than 1, then we can say that a decreases. Okay, these are the two properties of this logarithmic function. And here there is one more thing to identify is a is always greater than 0 and a is not equal to 1. Okay, these are the 2 points that you have to remember, that the base is always greater than 0, it cannot be negative, and it is not equal to 0 also, and it is not equal to 1. Okay, next, the natural logarithmic function. In the previous week we have seen natural exponential function, right? Natural exponential function. Now simply this natural logarithmic function is inverse of this natural exponential function. Okay, and we have discussed before that in natural exponential function the base is e, right? Same here in the logarithmic function also, the base is e, log e to the base x, and this also can be written as ln x. Okay, this is the special representation of this natural logarithmic function. Okay, this is only possible when the base is e. Okay, the basic thing that you can say is, have to determine whether it is a natural logarithmic function or not is simple. If the base is e, then it is termed as a natural logarithmic function, and this can also be written as ln x. Okay, next, solving the exponential equations. For example, here we are given 4x plus 1 is equal to 128. We have discussed before, when we are given something in this exponential form, have to convert this into logarithmic form. It's simply log 128 to the base 7, that is equal to 4x plus 1. So 4x is equal to log 128 to the base 7 minus 1. X is equal to log 128 to the base 7 minus 1 by 4. Okay, let me write it clearly. Minus 1 divided by 4. Okay, now let's see the next question. E power 2x minus 5 is equal to 61. E power 2x minus 5 is equal to 61. Again, converting this into logarithmic form, log 61. Just a minute. Yeah, simply this can be written as log 61 to the base e is equal to 2x minus 5. That means ln 61 is equal to 2x minus 5. That means ln 61 plus 5 is equal to 2x. That implies x is equal to ln 61 plus 5 by 2. Okay, this is how you have to solve the equations using the logarithms. See, previously we have discussed some properties and laws in the exponential functions. Similarly, there exist some properties and laws for logarithmic functions even. See, log 1 to the base a is always 0. The base can be anything. It can be in this interval or it can be in this interval. If this is 1, then it is always 0, and log a to the base a is always equal to 1. Okay, these are the two properties set for logarithmic functions. And see, clearly we have some laws. Log m and n to the base a is log m to the base a plus log n to the base a. This is somewhat similar to the exponential laws that we have seen before. Okay, you have to always remember these properties and laws. These are the key and these are the heart for this entire logarithmic functions topic. If at all you want to solve any function, any question based on a logarithmic function, you must have all these formulas, properties on your fingertips. That makes your problem very, very easy. Okay, and the questions mostly are asked based on these laws and properties itself. The same is for exponential functions also. The same satisfies. You have to learn all the laws and properties so you can solve the questions very easily. Okay, now let's take an example to understand these laws much better. Okay, first thing, for suppose you are given log 2 to the base 3 into 4. This is not 3.4, this is 3 into 4. Then this can be written as log 3 to the base 2 plus log 4 to the base 2. Remember, the base must be same. This is also same in the condition of, this condition must be true in this case of exponential function also. Remember? Do you remember that? And next thing, if you are given log 3 by 4 to the base 2, then this can be written as log 3 to the base 2 plus it's minus log 4 to the base 2. Remember, one more thing here, one thing important is log 3 by 4 to the base 2 is not equal to log 3 to the base 2 by log 4 to the base 2. Okay, remember this point. Next, similarly, what are the properties that we have left? Yeah, for example, we have log 2 power 4 to the base 3. Then this can be written as 4 log 2 to the base 3. Okay, these are the basic properties for the logarithmic functions. Okay, next, change of base rule. See, here log a to the base b. This is what you are given. Then you can write this as log a to the base c by log b to the base c. And similarly, if you are given log a to the base c into log b to the base c, then you can write it as, sorry, it's b, then this can be written as log a to the base c. Check the bases properly. Check the bases. See here, log a to the b can be written as log a by a base to the c by log b base to the c. Here the bases must be same, and here previously I told you one, this is something different. Okay, this can be written in this form when you are given log 3 to the base 4, but not in the case of this. Okay, remember properly, I'm erasing this, you may not, such that you'll not get confused. Okay, don't get confused in this case, this is different, and the next case we have discussed now is different. Okay, and here you may come across many number of problems using this change of base rule. This may help you in simplifying the problems. You can just compress the terms. Okay, next, see here we are given a question, log x to the base 8 minus log x to the base 16 is equal to 0. Okay, you have to use the change of base formula to solve this question. Okay, now let's see how to solve this question. Okay, first, log x to the base 8 minus log x to the base 16 is equal to 0. Okay, here we can write this as log x to the base 10 by log 8 to the base 10 minus log x to the base 10 by log x to the base 16 to the base 10. Here the property we used is log m to the base n can be written as log m to the log n to the base c. Okay, this is the property of logarithms we have used. Okay, let me see here, there is an extra slide. Yeah, there is an extra slide. See, log x to the base 10 by log, so 8 can be written as 2 cube basically, and here we have base 10, and log x to the base 10 by log 2 power 4 16 can be written as 2 power 4, that is equal to 0. And we have previously discussed a property that log a power 4 to the base, something can be the base, is 4 log a to the base c. So here we can write this as 3 log 2 to the base 10 and 4 log 2 to the base 10. That means the resultant equation is 10 by log 3 log 2 to the base 10 minus log x to the base 10 by 4 log 2 to the base 10. See, now taking log x to the base 10 and log 2 to the base 10 in common, what do we get? 1 by 3 minus 1 by 4. This must be equal to 0. This is not equal to 0. See, here this is non-zero. This term is non-zero. That means simply we can say that log this must be equal to 0. Let me see here, there is some extra slide or not. Okay, unfortunately there is no slide. Let me solve this here in this cap. Don't get confused. Let me solve this here. Log x to the base 10 is equal to 0. Now converting this logarithmic form into exponential form. Sorry, this is 0. That means 10 power 0 is equal to, 10 power 0 is equal to x. anything power 0 is 1, so x is 1. Okay, so for x equal to 1, we get this equation, this equation gets satisfied. Okay, now let's see the next question. See, here we are given log x plus 5, something is the base, so we don't know what the base is. X minus 5 is equal to 4 log 2 to the base 2 plus 2 log 3. This is what we were given. Now we have to solve for x. Let me write it more clear. Equation is here. Log x plus 5 plus log x minus 5 is equal to 4 log 2 plus 2 log 3. This is the equation we are given. See, we have discussed a property that log m into n to the base some c. Base can be anything, can be written as log m to the base c plus log n to the base c, right? See, here we are having log m to the base c and log n to the base c. M is x plus 5 and n is x minus 5. That means this can be written as log x plus 5 into x minus 5. Okay, the base is something given, we don't know what is the base, let it be. And see here, solving this further, let me go to the, okay, so you have to solve it here. Okay, let's take a blank screen. 4 log 2 plus 2 log 3. Okay, so how do we write this in a simplified form? See, we have discussed a property that log m power n to the base c is n log m to the base c. So here this is in this form, that means this can be written as log 2 power 4, and similarly this can be written as log 3 square. Okay, have you understood? So this can be simplified as log 2 power 4 plus log 2 power 4 plus log 3 square, and further this can be simplified as log 2 power 4 into 3 square. So now both are in the logarithmic form, so we can compare these two. That means see, x square minus 5 square. See, a plus b into a minus b is a square minus b square. So x square minus 5 square is equal to 2 power 4 is 16 into 9, that is 144. X square is 144 plus 25, that is 169. So from this we can solve. The x will be 13. Okay, I think x will be 13. We should not consider minus 13 because this must be always greater than 0. Okay, and now see, here we are given all the properties of the logarithms with the examples. So if you just go through this table, you can get many ideas, and practice is more important. You have okay, let me write it clearly. Practice. Okay, just memorizing these formulas alone will not help you. Okay, you have to practice many problems such that you can just memorize the formulas. There is no need of sitting and by hearting all those formulas. Once just you have to read the formulas twice or thrice and then start solving the problems. After solving few problems, you yourself can remember those formulas. You yourself can get the different approaches how to actually solve the problem. Okay, see, here you are given the product property, quotient, power, everything. See, everything is discussed in detail. So just go through this table and keep on practicing more and more problems. So that is the key for your success, that is the key for your good result. Okay, and that's all for today. Thank you so much. Let's meet in another video.